In this video, I'll be showing you how the compile and link process works with regard to the C++ compiler. So if we start with a very simple little example.cpp file, I need to get rid of that for now. I can convert that into an executable by running it through a compiler and a linker. And I do that from the DOS prompt. And using the Microsoft C compiler, the way you do that is you go cl compile link and then the name of the file, which is example.cpp. And away it goes. It compiles and links the project. And if I actually do a dir, I can see I've now got an executable. So I can actually run that and away, and it actually displays the output as shown in line 4 in the window below. So let's try and understand what's going on here. And I can do that. All I need to do, I'm running these through the command prompt, but I can run them in the command prompt in the editor just to make it a little easier to see because it's different, bigger colors. So let's go through that one more time. If we go dir, we can see we've got an obj file and an exe file. So what are they? Well, the obj file is the object code, which is produced by compiling the C++ file, and the executable file is the output of the linker, which combines all the object code to produce an executable code. So we can see that in action. If I just delete the executables and the objects, we'll see that there's no files there anymore. So if I now run that compile link phase, but I actually just ask it to do just the compile on the file. So I'm asking the compiler linker to just do the compilation stage. We get a warning there because it's complaining about exception handling, and it's actually asking us to use this switch because it's saying exception handling unwinding requires that switch. So let's make it happy. If I run that again with that switch, I don't get the warning. So what we've done is we've just compiled that file, and if I do a dir, you'll see I just got an obj file. I haven't actually got an executable because I asked it just to do the compile stage. Now I can actually do the link stage using the same tool by just actually passing it the object file. Okay, so now it's not going to do the compilation stage, it's just going to do the linking stage. And there you go. It's now, if I now do a dir, it's got an example.exe. Now if I run that example.exe, it produces the output. So when you're using a C++ compiler, there's always a two-stage process. The first stage is the compilation stage, and the second stage is the linking stage. And the compilation stage creates the object files, and the linking stage creates the executable files. And you can see that in action. So, if we delete the, clear everything out, and we've got nothing there, you'll notice that if I actually introduce an error into this file, it now finds that it failed the compilation stage, and you'll see there's nothing's produced. Because the error was in the compilation stage, the linker doesn't even get invoked. So no object file is created and no executable file is created. Now we can actually even introduce extra files. If I include a message.h file, spell it properly. If I look in that file, we're going to move this message function into two files. So this file has now disappeared into another file. Okay, so if we actually open up the message.cpp file, you see we've actually moved the file, the function, into another file. And why are we doing this? Well, because now when we try and compile, let's start with a clean slate again and we'll see what we've got here. We've got nothing here. If I try and compile the example, I now get a linker error. So if you remember before we had a compiler error, but now we've got a linker error. And it's basically saying that, because if we do a dir, we can see that the only object file that I've got is the example.o. And the example.o was created from the example.cpp. And if I look at what's in there, there is no definition of the function message. That function is not defined there because the function is actually defined in this file. And exactly, so that's what the compiler, the linker is actually telling us. It's saying, well, we've got a reference to this function, but I can't find it anywhere. And that's because it hasn't been compiled, because we haven't compiled that message.cpp file. So we could actually fix it in several ways. We could actually just, for example, go like this. So right now we're going to compile the message file. And again, we've got our warning about how, so we get rid of the warning. So now it's actually compiled the message file. If we do a dir, now we've got a message.obj. So we can actually now make this work by passing in the obj file. So what we're now doing is we're going to ask the compiler and linker to compile the example.cpp, but also link in the message.obj. And lo and behold, it now produces an executable. We've now got rid of our errors, and if we run that thing, it produces a hello world. Now, of course, what we could have done is a much simpler thing. What we could have done is actually just gone, let's find that. There's no point in doing that. What we could have done is just done this. And what that means is that the compiler is going to compile two files and then it's going to link them together. And there it is. And you can see it there in the output. It actually compiles the two files and then it links the two files to produce the output. And there you go. There's our example.exe. Okay, so what does that all mean? Well, it just means that the process to build an executable is a two-stage process. It's the compilation stage, which produces the obj file, and then it's the linking stage, where the obj files are used to produce the executable. But it's always important to note, this is why you can get two different types of errors, because if it fails in the compilation stage, so if I introduce an error right here, and I go, if I delete all my star.objs, so there's no obj files, if I run that compile link again, you'll see that it failed the compilation stage for the example.cpp. So if I do a dir, you can see that it's compiled the message one okay because it's produced the obj file, but it has failed to compile the example.cpp file. And while there's an executable there, that wasn't actually created, because if I delete the executable and I run that again, there's no executable produced. Because, of course, because the compilation stage always runs first and the linker stage always runs second. And there's no point in actually trying to do the linking if the first step failed. And likewise, if the linker stage fails, you get a different error message. So it's always worthwhile knowing that It's a two-step process, and the first step is the compilation, and the second step is the linking. Now this is the Microsoft C++ compiler, but the same thing applies to other compilers. Like if you use the GNU compiler, which is known as gpp.exe, and if I compile example.cpp, it will give the same sort of errors. It'll say, once again, it's saying there's an undefined reference to message. And again, what I have to do is actually give it the message as well. And in this particular case, the default for the GPP compiler, the GNU compilers, is to produce this a.exe file. If I run a.exe, it'll produce the output. That way there. Okay. And so what I can actually, and one other thing with a GNU compiler, you can actually set the output to be like a GNU, let's call it GNU example.exe. So you can actually tell it so rather than produce an a.exe, you can tell it what it should produce. And so if we do a dir, we'll see we've now got the GNU example.exe that we can run. Right. So basically all C++ compilers work the same way. They all have this compiler and linker stage, and the compiler stage converts the source code into object code, and the linker then takes the object code and produces the final executable. And that's about it. That sort of should hopefully demystify what's going on, and why you get two different types of errors, why you get a compiler error and a linker error. And one is produced by the compilation stage, and the second is produced by the linker stage. So, and the good thing is, that's why when a lot of people get confused by the linker stage, because it doesn't seem to make any sense. But the thing with linker errors, you've always got to understand what the linker is trying to do is trying to make all the pieces of the puzzle fit. So when we actually ran this, I'll use the C++, the Microsoft one, because it gives a better error. When we compile this, when we try and build this project with this one file, it's saying I can't find this function called message. And that's because nowhere in the command line have we actually told it how to find the message. There's no definition of message in that command line. And only when we actually tell it that here's the message function, we add that to the command line. Now we get the warning because of the unwind semantics, but we get an executable. And that's basically it. Now, why would you do this? Well, if you're learning C++, it's really quite easy to use the command prompt to practice. And a good example of this is this vector function here. If I open that up in the editor, this function was actually, this code was copied from this page, okay? And it explains how the standard vector works. It's creating a standard vector here, putting some numbers into it, and then adding numbers to it, and then it's printing them out, as pretty much as the comments suggest. So if I wanted to understand how all the standard library works, I can take examples from the C++ reference, type them into a file, and then if I go and compile that vector, and if I add my EHSC to get rid of the warning, it produces me a vector.exe, and then I can run that. And I get the same results, the expected results, as was this was the expected output, and this is what I got. And likewise, I could use the GNU compiler to do exactly the same. And the only thing to remember when you run the GNU compiler, it produces an a.exe, and there's the same results. So what you can do is you can actually use reference sources like cplusreference.com and work your way through all the programs, all the examples, getting an understanding of how it all works. And of course you can change these codes to do whatever you like and play around with them. And just using the command prompt, it's possible to then work your way through all of the tutorials or all of the reference information and start understanding how all of this stuff works. So that should be it. That should be enough for now. But that's basically how you would go about. There's a little understanding of how the C++ compiler works and the linker, and how you can actually use a command terminal to work your way through C++ reference material, teaching yourself how the C++ language works.